talk about the topic on the screen there, but I've got a little bit of a problem in that I don't actually know how to pronounce it correctly. I've surveyed a few people, and some people say PaaS for this PaaS word. Talking to my colleagues in America, they tend to say PaaS. And then there's the very Aussie way of saying it, PaaS. Get your PaaS into gear, love. I personally prefer PaaS. So you're going to get to see pictures of donkeys for the rest of my slide deck, which I personally think is better than pictures of asses, but you know, each to their own. So today I'm going to give you just a really quick intro to what PaaS is, and then a bit of an intro to OpenShift. That's just to set the scene. I really like to spend most of the time doing a demo and addressing any questions. But before I go any further, I'd like to just find out a little bit about you guys. So I'm assuming that everyone here is a technical kind of person who understands the terminal and Git. Was that a pretty safe assumption?
No, I write PHP.
So I guess we're going to find out what kind of languages. Who writes PHP? Yeah, anyone else willing to admit it? A few, okay. Pythonistas, Python people, a few. Perl, yeah. What about Java? No? A few. C, C++, .NET, Assembler, something else. Okay, so a pretty good range of things. So what's this PaaS thing anyway that I'm talking about? So PaaS stands for Platform as a Service, and as all the other as a service acronyms are, it's talking about cloud computing as a resource over the network, usually the internet. So the resource in this case is an application platform. So what does that mean? It's a platform that may include things such as the web server, the programming language, runtime, say databases, dev tools like cron or your CI server. Basically everything other than your code and its data can be part of the platform. Of course, PaaS isn't the only thing in the cloud. A lot of the time when I go around and start talking about PaaS, people say, oh yeah, EC2. No, EC2 is infrastructure as a service. So that's one layer below, and that's things such as your servers, your VMs, storage, networking services, the infrastructure level. Then we also have software as a service, of course, the most prominent example being webmail, like Gmail or Yahoo, but also things like games, CRM systems, and the like. So one way you can look at this is it's a bit of a sandwich, I guess, different layers of abstraction. So you've got your infrastructure level at the bottom. If you buy infrastructure as a service, you're going to have to still set up those servers, put an operating system on them and whatnot. The next level up is your platform as a service. So that's going to give you all of that type of configuration already for free. And then the level on top of that, of course, your SaaS. So if you're using someone else's software then on the web, then you're using SaaS. And you can layer these things on top of each other, but of course you don't necessarily have to. So why bother with all these complicated acronyms? Well, there's quite a few advantages. I think the big one for developers is focusing on your code rather than the config. You know, we're not sysadmins. We don't want to spend all day in config files trying to figure out what's wrong with the web server. This kind of abstracts all of that kind of thing away. Also speed. If you can deploy quickly, you can redeploy quickly. You can iterate, all that good agile stuff, and keep improving your product. You have a fast cycle time. Also, it's just convenient. It depends on the individual PaaS you're using, but with a lot of them, deployment is as simple as a git push. And it's something that's already part of developer workflows, it's something that's quite familiar. Also scalability. Again, it depends a little bit on the PaaS that you use, but scalability is something the platform often will handle for you automatically. So you can start some app and just start small, push it out there, and then when all of a sudden you're getting 1 million hits a day, it can scale up without you having to worry about it or even having to have thought about that in advance. Also efficiency, rather than going and buying all your own servers and then only using a small part of the capacity. If you're sharing, obviously it's a more efficient system. And also using the system, the platform itself can know if no one's actually touching your app and idle it down. And then finally, the polyglot capabilities. So, I mean, you're probably well versed in a particular stack that you like to use, but hey, what about if you wanted to just try running your app on some other stack, or just try out another stack to see what it's like? Using a PaaS makes that really easy. All the config's done for you, so you can just quickly get something up and running and try it out. So Red Hat's PaaS is called OpenShift. It's open source, written in Ruby mostly, and yeah, available for contributions. So OpenShift actually is a term for 3 different projects though. So we've got OpenShift Origin, which is the upstream. So that's where you can get in, you can grab that code and run your very own private cloud platform, do whatever you want with it. We also have OpenShift Online, which runs on Amazon. So that's our public solution. So you can go on there, anyone can sign up for free and run 3 free apps in the cloud. So that equates to 1.5 gigs of RAM and 3 gigs of storage that you get for free. There's also a paid tier, which unfortunately isn't available in Australia. So you need a US credit card and whatnot to be able to access that. And then finally, there's OpenShift Enterprise. So if you're a big company and you want Red Hat's help to run a cloud privately, yep, there's a solution for that. So how does it work? I'm going to steal a pretty diagram that someone else made to help with this, because this gives a pretty nice overview. So we've got, where do we start at the top? So it runs on RHEL, Red Hat Enterprise Linux. So this is enterprise grade stuff. It can run in all sorts of different environments, as you can see there. And we have our various RHEL nodes where the applications reside, and also our broker. And there's a RESTful API you can use if you want to contact that broker directly, as well as other tools available. And so inside those nodes, we have gears. So this isn't an LXC-based system like some of the others. These containers are secured with C groups and SE Linux. So that's how they do the containerization. And yeah, high density, of course, comes along with that model. So in terms of the developer workflow, so you create your application your usual way. There's plugins for Eclipse, and more recently IntelliJ has added some things, but most people just prefer to use the command line. So you create your application, spin something up. You create a gear in the cloud, so that's our term for the container, and inside that container you have cartridges. So cartridges are the actual application components. So they've got some examples there: Java, PHP, Python, Ruby. The 3 main databases are MySQL, Postgres, and Mongo. And other notable things that aren't there, Node.js is supported. I think that's the main built-in one. But because it's all open source, there's anything you can think of, someone's probably already built a cartridge for it. And there's also the custom cartridge for you to do your own things that way as well. So you do your code, do a git push, and just push it onto the platform. It's as simple as that. And yeah, there's some extra tools to help you out. So, support for Maven, for Java builds, and of course JBoss and all the enterprise grade stuff that goes along with that. Jenkins you can add with a click of a button, and yeah, of course, Apache. And then the auto scaling. So I think everything other than the custom cartridge can scale by default, as long as you create it as a scalable cartridge to start off with, and that's using HA proxy to load balance across your different gears. Where am I? Here we go. So we've gone there. All right, that's the theory. Let's have a bit of a look at it. So I've got a demo. I'm going to make a Java app. Sorry about that for every other language group in here. And it takes around about a minute to a minute and a half for Java, maybe about 50 seconds if it's Ruby or PHP. So to fill in that time, I've got a bit of a game. Has anyone heard of Minute to Win It? Yes? No? Okay. Well, I'm going to need 2 volunteers, and yes, you will win a prize. Can I get some volunteers? Come on, don't let me be the only one at the front. All right, 1 and 2. All right, sweet. So there's a Minute to Win It challenge called Hanky Panky.
Is this a code conduct?
No code of conduct violation. All right, so the rules are you have as long as it takes, and it's normally a minute. In this case, it's going to be you'll be racing OpenShift, and you have to take every tissue out of the box individually with one hand.
Where's the opening the box?
Yeah, so you can open the box in advance. Yeah, you can open the box. All right, and we're going to race and see. So normally it's 160 tissues. These ones have 224. But this will take more than a minute, so it evens out. All right, so are you ready?
False start.
And all right, go.
I'm trying to think of an analogy.
All right, OpenShift's doing its thing. You've got to beat OpenShift to get the prize. We're creating. Oh, there's a little bit of cheating at the end there. Hey.
I'm not quite as good as my wrist as Tom. I think at one point about 70 came out at once.
Yeah, I think there was a little bit of cheating there, but all right. We have a winner and OpenShift's still going, so. Here you go. It's your prize. Well done. That was beautiful. All right.
Now you have to clean it up.
Good thing there's a break next. All right, so OpenShift is doing its thing. As you can see, command line tool is called RHC. It's a Ruby gem, so you need Ruby and Git installed, and you just go gem install RHC. And then creating an application is just simple as app create. I gave it a name. So I'm using one of the JBoss demo applications, which is called Greeter, but I've modified it slightly to do insults instead of normal greetings. So the command was just do that, and then the name of the cartridge I want, which is JBoss. And scaling, no, because I haven't added that option. So as you can see, so the broker went, it found me a gear, it set up DNS, and now it's given me some details. I've got the URL of my new app, and that's the kind of standard form. You set a domain when you sign up, so my domain is codemiller1, and then it's your app name -that.rhcloud.com. You've got SSH details, and your Git clone is done automatically for you. So if we now go and have a look in there, see, so by default, this is what you get for a Java app. You've got a POM, you've got a .OpenShift directory, which is where all the OpenShift config is, and you've got a deployments directory, so you can just drop binaries in there if you want, just to chuck your WAR file in there, but you've also got source, so we can put the source and it'll be built with Maven. So in .OpenShift, we've got a few things. So marker files, it's just a way of setting things, like if you want, for instance, hot deployment, you just add a file in there. Extra config, so that's the JBoss config if you want to alter it, and action hooks, so you can add scripts in there to do various things during the application lifecycle if you wish to. So I'm going to set up a Greeter app to run on OpenShift. So to do that, just copying the source across and the POM. The POM is going to need to be edited slightly. Oh, this is a bit messed up. This is a recording, so, all right, never mind, that might not work. Anyway, basically all it was is adding an OpenShift profile, for those that do know Maven and Java, at the bottom. So that was the only change to make there. So if I add those, type really fast. All right, so now I've got my app code there, but I'm going to need a database, so I'm going to add my SQL. So do a cartridge add. So to be fair, I didn't speed up that first part. That really was how long it took to create the application, but these bits I have sped up. So add a cartridge, you get some details. Everything's in environment variables. So you've got there how the connection string is made up, and you can use those in your app wherever you need to. This is Java, but obviously it's going to be whatever you're doing. You'll probably need to change some kind of config and put in those database environment variables. So your app knows where to find your database. So in this case, I'm getting rid of the default or the greeters data source, changing the persistence XML, which again looks like it's been balked in the recording, so never mind about that. And commit it. Go. Right, now let's say I want to build my app on Jenkins and then have it sync across when it's done if the build is successful. So to do that, I'm going to add the Jenkins application. And while that's doing its thing, I might just show you over here. So this is what you get out of the box when you build a Java app. So it's just a standard hello world kind of page. And when you add Jenkins, you just get, as you expect, your regular Jenkins there, and when you do a push, then you'll see your app building before it syncs across. So now I've got Jenkins. So I'm going to add the Jenkins client to my app. And then when I push, rather than it going directly, it's going to be built on Jenkins and synced across. So add that and commit it. So I haven't done a push yet. That's obviously takes a bit longer, so that's why I'm doing everything all in one. Another thing you can do that's a more recent feature is keeping deployments. So you can easily roll back to previous versions that you've pushed. So I'm configuring it there to keep the last 5 deployments. And now I'm going to finally do the push and push all that code. And when you do that, you see it executing all the different things in the build lifecycle. And so it's because I've added Jenkins, scheduling it on Jenkins until it's successful, and then there's our code. So you can see the app. Here's the app, although I've added obviously a donkey and some greetings. So if I add a name, I'm going to get, ooh, okay. That's not good. Okay, I might not have network connectivity. Anyway, trust me, it insults you. Worse than that. Yeah, pretty much. Okay, so now I'm able to do a deployment list. So now I've got more than one deployment, so I could easily, very quickly roll back. Welcome to the madhouse. So you can at any time do an app show, which is going to give you a whole bunch of details about your app, including the database details. So the point of that is I might want to do, say, some port forwarding, which is another easy command built in, so that I can then grab my data and put it in that database, because JBoss app by default just uses an in-memory database. Now we've got one that's actually a proper database, so change that. And then once you've got your port forwarding, oh yeah, so here's my import SQL with all those lovely Shakespearean insults. So then you can just use your regular MySQL or Postgres or whatever it is you're using, grabbing those credentials. Oh dear. There we go. And import in that data. What else have I got? Oh, SSH. You can SSH into your gear and take a look around. So this is what you get. So we've got a few different things. We've got different folders for the different cartridges that I have, so JBoss, Jenkins and whatnot. We also have, if you look in JBoss, yes, your typical JBoss directories there, if you're familiar with that. Then we have the application root. Has a few things in it. So we've got our repository there, so obviously that's the clone of our Git repo. We also have a directory there called data, and that's significant because it's persistent. So unlike some of the other solutions out there, there is a way to keep things persistently across builds. You just have to make sure you put them in this data directory. If you don't want things wiped away, obviously, when your Git repo is cloned again. So we've got SSH. So very quickly, don't know how I'm going for time. Chris, do I have long?
5-ish minutes.
5 minutes? Okay, so quickly finish this off. All right, so deleting the apps, again, just another RHC command. And now just to quickly show you a scalable app. So Ruby that scales using Ruby 1.9, and it's as simple as adding -s. So I want it to be a scalable app. And then now, of course, we have scaling, yes. And I have sped this up, but yeah, I think it was about 50 seconds to spin that up here on my hotspot. Okay, so once I've got that, the next step, so normally this is auto. You wouldn't need to do anything. If you get enough traffic on your site, there's an algorithm that will automatically scale up for you. But to actually demo that, that recording's done weird things, but anyway, all you do is add a disable auto scaling marker file. So just literally touch the file and then add it with Git. And push that, Git commit and push. I think it's like in the word wrapping. This is all the stuff that you see when you push something. So this time there's a few different things in here. You can see that HA proxy is now involved. Yes?
The gear that you're creating, is that on the back or the cloud?
No, in the cloud, yeah. This is all online. I don't think it may have network issues, but this is what I loaded earlier. So yeah, here's what you would get out of the box. If I take away full screen, you can see where that is. So it's Ruby that scales -codemiller1.rhcloud.com. Just the demo page. And then also if you then, because it's a scalable app, go /HA proxy status, and then shows you all the details of the scaling. And if you then scale it up, so to do that, there are a couple of different ways, but one way to do it is to SSH in and just run the command add gear with the name of the app, the UID, and the namespace, which again is not printing so nicely. If we do that, and then do an RHC app show, it shows that now we've got 2 gears. So it's scaled up and now balancing the load between the 2 instances. So I said that out of the box you get 3 gears for free. So this is the web console for OpenShift Online. So if you go to OpenShift.com and go sign up and then sign in, you'll get something like this, although probably with no applications. So I'm using 2 out of my 3 gears. So Jenkins is taking one up. I've got this insult greeter app, which you can see the cartridges. It's got JBoss and MySQL. If this was a scalable app, MySQL would obviously have to be in another gear, because when you have a second instance, you need to be able to share the database. Obviously, you don't want a copy of it. So with three free gears, obviously you can't use Jenkins and have a scalable app. We'll have nowhere to scale. So this gives you some functionality you can do through here. So you can add apps this way if you prefer, rather than the command line and delete things and whatnot. But yeah, the command line definitely has the full functionality. But some people like the GUI approach instead. And I think that's most of what I wanted to demo, but does anyone have any other questions? Yeah?
Okay, so scaling when it comes to database, when you're scaling your Ruby code, I think that's easy. You just export service. How does the scaling happen on MySQL?
It doesn't. It's not a feature we have yet. Okay. I don't think they're working on it, but yeah, well, we don't scale the database as yet. You can only have a bigger gear, so you can have, we have different sizes of gears, so there's small, medium, and large. Large, I think, is 2 gig from memory, so yeah, all you can do is get bigger at this stage for the database tier.
What do you use to define the containers? Do you use like other chef or something from Rome?
What's behind it?
The nothing containers, the cartridges.
As in, how do you build one,
Yeah,
or?
what do you use to? Do you use like some sort of domain-specific language to define them? What does it look like?
Okay, that's probably a bigger question that I have time to answer comprehensively, but yeah, there's some YAML files you need to have, a few different bits and bobs. It's all open source, so if you're really interested in that side, I'd recommend going to the OpenShift Origin site, because you can look at all the pieces that run this.
Do you have a contribution?
No, it's just all capital tomato
Yeah, you can definitely make your own cartridges. It's not as hard as you may think. I don't know.
There's one little bit. Most of the cartridges, at the end of the day, are just using RPMs. So they're using the same versions of Perl, Python, Ruby, etc. that are Red Hat installed. So you can run your applications outside of OpenShift as easy as you run them within. One thing OpenShift's given Red Hat is much newer versions of Perl, Python, Ruby, MySQL, Postgres to play with. You're not restricted to our stock standard RHEL releases. Right.
That looks like it. So everyone please thank Katie.